Hello here, welcome to my channel. So in this tutorial I am going to show 6 important parameters, 6 climatic and biophysical parameters. So I will explain one by one how we can prepare it, how we can map it. First see, this is EVI, Enhanced Vegetation Index. I will show you how we can prepare this Enhanced Vegetation Index. It ranges minus 0.162 plus 0.78. Then I'll show you how we can prepare leaf area index. It's range 0 to 2.71, and then surface cover fraction 0 to 0.71. Then I'll show you how we can prepare evapotranspiration, right? Then it is range 0 to 3.91. Then transpiration, it's range 0 to 280. Then this one, evaporation, range 0 to 15. This is Birbhum district, and I'll show you everything how we can prepare and what are the importance of this parameter. It is a total loss of water from land surface to the atmosphere. So it mean is the evaporation. Two term is there, E and T. E mean evaporation. Evaporation mean what? Evaporation mean evaporate. Okay, so I'll discuss little bit theoretical perspective about these 6 parameters. First I will discuss about the ET. It is a total loss of water from land surface. So evaporation, definition of evapotranspiration is the combined process of evaporation from soil and water surface and transpiration from the plants, from the forest, from the living organism. So we can use ET because ET is one of the key indicator of the water energy nexus and help assess in various fields like to assess groundwater research, crop water demand, drought condition. In many perspectives we can use evapotranspiration. Then if we separate these two terms, E and T, and T means transpiration. So transpiration is the loss of water vapor from the plant to tiny process, that's means stoma, in leaves during the photosynthesis and respiration. So we can separate E and T using remote sensing data. So it indicates vegetation water use and directly linked to plant health, biomass and groundwater uptake. High transpiration can increase the groundwater stays, especially in arid and over irrigated region. And what is E? Evaporation is the, E mean evaporation, is the conservation of water from liquid to vapor from open water, soil and wet surface. So how we can use for our study, because it is a major component of ET and directly depend on temperature, solar radiation, humidity, wind speed. So in ground state study, we high evaporation means more surface water loss and low research potential. So I linked with groundwater stays, groundwater research, so we can use in many perspectives also. Then our main indicator EVI. EVI, Enhanced Vegetation Index, is satellite based product, and I will show you how we can prepare from Landsat Data. Okay, that measures the vegetation greenness and canopy texture. Actually it is the improved version of NDVI, right? Because it reduces the atmospheric and soil background effect. And most important is higher EVI indicate dense healthy vegetation, lower EVI indicates sparse and staged vegetation. EVI is often used to estimate LAI, leaf area index and evapotranspiration. So from EVI we can prepare LAI and ET and also SCF. So surface cover fraction represent fraction of ground surface covered by vegetation. So this is a simple fraction. And SCF held estimate how much surface is vegetated versus bare. Higher SCF means more canopy cover and higher transpiration, lower direct evapotranspiration from soil. So let's discuss first about the EVI, how we can prepare it. If you see this website, Landsat Enhanced Vegetation Index. What are the formula? See this formula. So this product shows the EVI range -1 to +1. But if you see here, EVI, Enhanced Vegetation Index, so its valid range -10,000 to 10,000. So how we can convert into -1 to 1? So For Landsat 8 and 9, this is the formula. Actually, EVI formula is G multiplied by near infrared minus Z. So if we consider Landsat 8 and 9, near infrared mean band 5, then red mean band 4, again divided by near infrared, that's mean here again band 5 plus C1. So actually C values as a coefficient for atmospheric resistance. One atmospheric and another C2 mean ground. So for C1, its coefficient is 6, and for C2 coefficient is 7.5. Then we'll use again red band and blue band. Blue band mean band 2, and then here L mean value to adjust the canopy background. So L equal to 1. So if you see other formula like this is EVI formula. Just I discuss EVI formula 2.5. Then near infrared minus Z, near infrared plus 6, multiply Z minus 7.5, multiply blue plus 1. So based on EVI, we can calculate leaf area index using this formula, Liu et al. 2012. They suggested leaf area index is 3.618. This is coefficient multiplied by EVI minus 0.118. And if we want to calculate surface cover fraction SCF from this LAI, then it would be 1 minus E, that is alpha I multiplied by LAI. So here alpha I, it is fixed 0.463 according to Simonek et al. 2009, and then we can estimate from this SCF, we can estimate the ET after using the Hargreaves and Samini 1985 formula. Then we can separate or partition E and T using this formula. T equal to ET multiplied by SCF, and E equal to ET multiplied 1 minus SCF. So using this formula, I'll prepare first using Landsat, using Google Earth Engine, then I'll show you how we can export and how we can prepare the map. And also I'll share the code. This is most important task. Here see, this is my study area, Birbhum district. Previously I have prepared one tutorial how we can upload our shape file. So my study area is Birbhum, so I have import my study area. Then I have defined this study area as a ROI, region of interest. And then this is actually how we can visualize the data. Map.center object ROI 8. And 8 mean here the zoom level, how we can zoom it, how we can visualize. Then I have, this is a time frame. So I have selected 10 years. So, this is variable start date. I have selected 1/1/2015. Then end date 31st December 2024. So 10 years, I have taken 10 years data, and I have used here Landsat 8. If you see this one, Landsat 8, TOA. See Landsat 8. So I load this data set, Landsat 8. Here the collection for Landsat equal to E image collection. So this is the code, and this is the data set link, right? Now filter. First we need to filter start date with end date, filter bound. That's when this is the area of interest. Then this is a cloud cover. We can reduce also. This is the 20%. So we can reduce to 10% also. Then function to calculate the indices. We need this C band. Near infrared band, which is band 5 for Landsat 8, then red band, band 4, then blue band, band 2. Okay, then based on this, we can use this formula like I have discussed earlier. EVI, Enhanced Vegetation Index, that's in 2.5 multiplied near infrared minus Z, then near infrared plus 6 multiplied red, then minus 7.5 because it is C2, then blue band plus 1, that's when L. Then it will reflect as EVI, right? Then see, according to rules, EVI valid range 10,000 to 10,000. minus 10,000 to plus 10,000. So then I update this mass according to minus 1 to plus 1. So lower value minus 1 and highest value plus 1, it will convert it. Then based on this formula, I have calculate LAI from the EVI. Okay, I follow this formula, Bock et al. 2002 and Liu et al. 2012. These literature are available, you should read it carefully. So EVI, see, I have discussed the formula. What the mean? 3.68 multiplied EVI minus 0.118. Then it will create leaf area index. Yeah, we can prepare leaf area index using the other software, the other instrument, like we can use the field instrument like LAI septometer. You can use it, right? See, I'll show you one picture. This is this picture. See, this is LAI septometer. We can measure the LAI using this instrument. Okay. So you can validate your result, your remote sensing based result using this instrument also. Right, so then, yeah, one important thing, LAI should not be negative. It should be always positive. You see my result, LAI, EVI, it should be negative also, but for LAI, it should be positive. It should be range from 0 because it's a canopy cover, right? So that's why we need to set lowest value in 0. Okay, so our lower bound 0 and our upper bound 6. Then surface cover fraction, again using the Semuk et al. 2009, I have used this formula, right? 1 minus exponential, as I discussed it, exponential what? Minus alpha, a alpha value means 0.463 multiplied LAI. Right? Then after Hargreaves and Samini 1985 method, I have calculated this EVI, right? Multiplied by EVI multiplied by 5, and it will convert it into ET, evapotranspiration. Then we can participate. Then we can partition this ET into two. One is T, according to formula, multiplied SCF into T, then E multiplied SCF, then subtract 1. See this formula again, if you see, multiply ET multiplied 1 minus SCF, here the formula, right? Then return to all images at all band here. EVI, LAI, SA, VT, T and E. Okay, all collection. Now I will export only median value. I will select, so I can avoid extreme values, lower extreme values and upper extreme values also. So that's why I'll use here the median. You can export all data set, right? You can use the time series data set of EVI, LAI, SA, VT, T for your research purpose. But in this tutorial, I will export only median value, right? Then I visualize it using this color gun, white and green, yellow, green, darkness. You can change it according to your need. Then I will add this layer to this map here. Okay, then I export this, I will export this. Okay, here I will create one folder, GE exports, and I export this name as this. Now what to do? Just we need to run this formula. I'll share this code. You can just copy and run this formula, right? Processing also done. See, this is our map. Is done. Nah? This is the zoom level. We can increase little bit here. Yeah, this is Birbhum district. Here the layer evaporation, then this is transpiration, then the ET, then SCF, then LAI, then EVI, right? Only median value. Now we have to go in our taskbar here, taskbar. Now we can export one by one. Like if you want to export the EVI, just we have to run it. Now it will save in your drive. You can save it in many way. It will save in drive folders. Okay, just run it. It will take time. Now how you can run it? See here. You have to run all this. Already I have done it. I'll show you how we can do it. Like see, this is my Google Drive. So I have to check here Drive. From here you can directly check here also, like after completing the task you can check here also directly. Source key, open in Drive. You can open this drive directly from here. Then you can download this data set. Okay. After downloading, what to do? After downloading, we have to process in any desktop GIS. Like I have used here ArcMap. So it is also open. So I can share you. Yes, it is already done. Here my Google Drive. My drive is there. You can check here also. We can check here also. GE Expert, double click it for opening. Yeah, it's working actually. It's completely depend on your network system. Yeah, it's working. See, under this GE export here the EVI median we just get it, right? So then we have to, it needs time, guys. It's the time. See here, when it will be completed, it shows like this symbol. Okay, then you need to download it by clicking this download button. See, I'll show you one example, then you can prepare other also. If you know how to process it, then you can skip it, skip this video also. Download it, complete it. Now I'll open it in my ArcMap from download section. Yeah, EVI, many file is there. This one, add it. Yes. So there is null value. If you check it, identity button, this is a null value. No data is there. So what to do? Just go to special analysis tool, this one, then extract by mask, this one. Then our input raster, just EVI median. Then our input raster officer class, here my study area between sub shapefile. Then I'll save it here in download section. For YouTube, EVI extension is, this is important task. What is the extension? Extension .tif. Save it and click it OK. It will take time to mask it. Then we will get only this value. In the meantime, if you have any question regarding this, if you want any video, then you can comment. Then I'll try to make video on it. See, remove it. Now see, this is our EVI. Then you can display it based on your needs, like you can classify it based on the standard rule. You should go through the literature, then you can find what are the standard rule. Yeah, I'll flip it. These are EVI. This way you can prepare all 6 parameters. Thank you for watching this tutorial.